There's a $300 billion object floating 36,000 kilometers above your head right now, slowly running out of gas. It's not broken, it's not malfunctioning, it's just thirsty. And until very recently, the only solution anyone had was to let it die, push it into a graveyard orbit, and spend $500 million launching a replacement. That was just Tuesday in the space industry. But something is changing, and it looks almost absurdly like a floating gas station. What we're talking about is orbital refueling, the idea that instead of building satellites to be disposable, we build them to be refillable. Send up a tanker, dock with the satellite, transfer propellant, fly away. Simple concept, right? Wildly difficult in practice. We're talking about two objects traveling at 11,000 kilometers per hour, in a vacuum, at temperatures that swing 300 degrees between sunlight and shadow, attempting something that looks for all the world like parallel parking, except both cars are moving, neither has brakes, and one wrong move vaporizes a $500 million asset. The companies trying to pull this off, Orbit Fab, Astroscale, and a handful of others, are essentially building the first-ever gas station network for outer space. And June 2026 marks the moment it stops being a concept and starts being a business. To understand why this matters, you need to understand how insane our current approach actually is. Right now, when a satellite runs out of fuel, which is the primary reason most satellites die, we don't repair it. We abandon it. A communication satellite the size of a school bus, packed with hardware that took a decade to design, is essentially thrown away because it ran out of hydrazine. That's the equivalent of scrapping your car because the tank hit empty. The person who looked at this situation and said, "Wait, what if we just didn't do that?" was Daniel Faber. He founded Orbit Fab in 2018 after spending years in the space industry watching this exact tragedy repeat itself. Faber's pitch was almost aggressively obvious. Satellites already carry fuel. They already have tanks. What if we standardized a refueling port, like a universal gas cap, and sent tankers up to fill them? His company raised seed funding, got into Y Combinator, yes, that Y Combinator, the one that backed Airbnb and Dropbox, and started building. The port they designed is called the RAFTI, Rapidly Attachable Fluid Transfer Interface. And look, I'm not going to pretend that acronym is cool, but the idea behind it is. It's a standardized connector that any satellite manufacturer can license and install so that one day any tanker can refuel any satellite, the same way any car can pull up to any gas pump. Here's the fundamental problem with space travel that nobody talks about enough. Mass is money. Every kilogram you launch costs somewhere between $2,000 and $10,000, depending on your rocket. And on a typical communication satellite, nearly half that mass, sometimes 40 to 50%, is fuel. Fuel you'll use up, mostly just to keep the satellite in its correct position against the gentle but relentless pressure of solar wind and gravitational drift. We call this station keeping. It's boring, it's constant, and it's slowly killing your satellite's lifespan, one tiny thruster burn at a time. When the fuel runs out, the satellite starts drifting. Within months, it's useless. So, operators have two choices: deorbit it, controlled disposal, or push it to a graveyard orbit, a few hundred kilometers higher. A kind of elephant graveyard for dead spacecraft that's becoming genuinely crowded. Neither option is good. Both are expensive, and both happen years before the actual hardware fails. Orbital refueling flips this equation. If you can top up the tank, even once, you can extend a satellite's operational life by 5, 10, 15 years. That's not an upgrade. That's a resurrection. Let me put this in terms that hit differently. The average geostationary communication satellite costs around $300 million to build and another $100 to $150 million to launch. Its operational life? About 15 years. almost entirely limited by fuel, not hardware. The electronics could keep running for 30 years. We're essentially scrapping a working $400 million asset because of a fuel bill. Now compare that to a commercial airline. Nobody looks at a Boeing 777 and says, well, it's been flying for 15 years and we've used up the fuel we originally loaded, so let's just sink it in the ocean. You refuel it. Every single flight. The concept is so basic, it sounds almost insulting to explain. And yet, for 60 years of the space age, we just never did it. Astroscale, the Japanese company that's been leading the charge on satellite servicing, already demonstrated autonomous rendezvous and docking in orbit with their ELSA-D mission. They captured a client's satellite, released it, tumbled it intentionally, and then recaptured it, all in orbit, just to prove it could be done. That's not a small thing. That's the equivalent of throwing your keys out a car window at highway speed and then catching them again. Now, I'm not going to stand here and tell you this has been smooth. It hasn't. Orbit Fab's early timeline slipped. Their first tanker, the Tanker 001 Tenzing, launched in 2021 to the International Space Station largely as a demonstration. It worked, but the commercial refueling market didn't exactly rush to embrace it. Satellite operators are notoriously conservative. These are billion-dollar assets. Nobody wants to be the first customer to let a startup spacecraft dock with their crown jewel. There's also the technical mountain of fuel compatibility. Different satellites use different propellants: hydrazine, xenon, Hall-effect thrusters running on krypton, and you can't just pump one into a tank designed for another. Orbit Fab is betting that the industry will standardize around their Rafty port. But getting satellite manufacturers to adopt a new standard is, let's say it's like convincing every country to switch to the same electrical outlet. Theoretically obvious, practically a nightmare. And there's the regulatory side. Rendezvous and proximity operations. Spacecraft getting close to other spacecraft are governed by a patchwork of national and international rules that were written long before anyone imagined commercial docking services. Getting approval to operate a refueling tanker near someone else's billion-dollar satellite involves a level of bureaucratic creativity that makes the engineering look simple. But here's the thing. None of these are fatal problems. They're friction, and startups are very good at friction. Which brings us to right now. June 2026 is shaping up to be the moment this industry either validates itself or faces a very hard reset. Orbit Fab's Tanker 002 is targeting geostationary orbit, GEO, which is the high-value neighborhood where most commercial communication satellites live. This isn't a demo. This is a commercial mission with paying customers. The first time a privately operated tanker refuels a privately operated satellite with real money changing hands in actual orbit at 36,000 kilometers altitude. Astroscale, for their part, is pursuing not just refueling, but full satellite servicing, life extension, inspection, even deorbit assistance for defunct satellites. Their Lexi mission is targeting GEO servicing as well, and they've secured contracts with the Japanese government and inked agreements with major satellite operators. This isn't fringe anymore. The European Space Agency has earmarked funding for in-orbit servicing. NASA is watching. The U.S. Space Force is watching. And every satellite operator with an aging fleet is doing the math. The long-term vision is almost science-fictional in how logical it sounds. You build a network of orbital depots. Think truck stops, but 36,000 kilometers up. Tankers resupply the depots. Depot trucks service individual satellites. Eventually, you have an actual infrastructure layer in orbit. Not just hardware passing through, but a persistent, serviceable, economic ecosystem. Orbit Fab has talked publicly about their goal of making propellant available in orbit for $20 per gram, compared to the cost of launching it fresh, which is considerably more than that. That's not just better economics, that's a different model for how humanity operates in space. There's something almost philosophical about this technology that I keep coming back to. We spent 6 decades building a civilization in orbit and treating every piece of it as disposable. Telescopes, weather sensors, communication relays, GPS, the entire invisible infrastructure of modern life, all of it launched with a built-in expiration date. Not because it had to be that way, just because nobody had solved the gas station problem yet. Now somebody is. And when that first tanker docks in geostationary orbit this June, it won't look like a moon landing. There won't be a famous quote. It'll be 2 spacecraft meeting quietly above the Earth, exchanging fuel, and going about their business. But what it represents is a shift from a space industry that consumes to one that maintains, from disposable to durable, from one-shot to sustainable, which honestly is the only version of the space age that actually scales. Next time, we're looking at the other side of this equation. What happens to all the dead satellites we didn't refuel? Tens of thousands of objects in orbit, some the size of school buses, some the size of a bolt, all of them moving at rifle bullet speeds. The space debris problem is already worse than most people realize, and the solution involves a harpoon, a net, and at least one very ambitious Japanese startup.